All right, go and take your homework handout out. There were 8 systems of equations to solve, and I told you 2 of them at least needed to be substitution. You can do all of them if you wanted to, I guess, by substitution, though some of them really didn't work that well for substitution. What would make a system of equations work well by substitution? Brecken? Good. If you can get a letter by itself easily, meaning as you look at the system, there's a plain old X or plain old Y just kind of right there. That's probably easy substitution. But like that very first one, I'm doing that one by the addition method. And what did you get for that first system for your answer? Okay, so let's see if we can figure out what the problem was here. I assume you got rid of the, well, I don't know, the Y would have like a 20, but the signs are different. The X would have a nice easy number like 6, but you'd have to change signs. Which one did you get rid of, X or Y? You got rid of the X. Okay, so you multiply the top by 2 and the bottom by 3. So that your top equation became
6x negative 3y equals 23.
And the bottom equation?
Negative 6 or 6x negative 9.
Initially 15y
Equals 72.
Okay, so the distribution wasn't the problem. Now here's a strategy tip. The little numbers are in the top. I would have changed the signs across the top. That said, it sounds like you changed them in the bottom. It's not wrong to do that. You're just going to get a lot of negatives here. So of course the 6 and negative 6x cancel. What did you get when you combined negative 8y, negative 15y?
23y.
Negative 23y? Okay, careful. Remember, add and keep the sign. So if I took $8 from you, then I take 15 more, it's as though I've taken 23. And here's where we really got to be careful with the combinations. The positive 26, negative 72, we're going to have to subtract to get
46.
And again, should keep the sign of the greater, negative 46. So when you divide both sides by negative 23, we end up getting y is equal to positive 2. And you said you had what for your y value? 2. And you said you did have 2? Okay, so somehow the problem came when you plugged the 2 back in. Which equation did you plug the 2 in for? Bottom or top?
I'm not sure.
All right, well, let's just plug it into one of them now.
The top one.
Top equation. All right, so if you plug the 2 in right here, this gives you 3x is equal to 13. Ah, okay. You moved the 8 over, but you didn't move it over as a positive. You moved it over as a negative. You left it negative. We need to move it as a, to get 3x equals 21, not 5. I think that's where you had the 5. And then when we divide both sides by 3, we get x equals 7. And so 7, 2 should have been our answer. Looks like we made a couple sign errors here that actually the 2 wrongs made it right for you. You got the 2. But then a little bit of another sign error here and ended up making a mistake to getting, I think you said 5/3 2 for your answer. All right. Questions on this? Did you all get 7, 2 by any chance? You're both good to go. All right, let's look right next to it. And this is one we could do by the substitution method, or we could do addition. We're going to let Noah tell us what he did.
I did the substitution.
You did substitution. So you left the top equation alone. 5x plus 6y equals 19. How did you rewrite the bottom?
Y equals 3x plus 7.
There we go. And then you took the 3x plus 7 and you just plugged it in for the y in the other equation. So that your top equation could now be rewritten
5x plus 18x.
well, for now, let's go ahead and show the step of the substitution.
3x plus 7.
And again, as long as you can be accurate, I'm not upset if you combine that step and do the distribution in your head, but for sake of showing it on the board, let's go ahead and show the plug-in. Now let's go and distribute.
5x plus 18x plus 56.
Ooh.
42.
Yeah.
Equals 17. And you get 23. X plus 23.
Keep the sign of the greater.
Negative 23.
So x apparently is
1.
when you plug the -1 in here for the x, we'll get y is equal to
10.
-3, +7,
4.
+4. So -1, +4 should have been our answer for this one. How many got -1, +4 for the second one? Neither of you got that. Did you all do substitution like Noah did? Okay, both of you did. Did you distribute correctly to get +18x, +42? No, that was the problem for you, right? You had the 56 or something weird like that?
No, I added the 7. Well, first I got a +1, and then next I just added.
Okay, so you had 10, 1. So you got the 1. You got, but it should have been a negative. You got a positive. So a little bit of an issue there. Maddie? Have figures. Okay, Brecken? Yeah, but you don't do it as often, so I don't give you the same hard time I give Maddie. All right, Maddie. Looking at the next row, I don't see a good substitution here at all. I see a good addition scenario. If you multiply the bottom equation by 4. So when you multiplied the 4 through the bottom, it gave you a new bottom equation of perfect. And then as you add, remember, these equations together, we get, and it does actually divide evenly. By 19, it gives us 6. So, knowing that, we can go back to one of the original equations. Did you go to this one, or did you go back to 3x plus 2y equals 19 with your 6? This one here? Okay, so plugging in the 6 here for the x, 3 times 6, move it over as a, and that'll give you 2y equals 1, so y equals, and so your answer was 6, 1/2. How many had the same answer on this one? 6, 1/2. All of you good to go on that one. All of you did the addition method, I assume. All right. Looking at the next one, again, I don't see a good substitution on this fourth problem, Brecken, but I can't do the addition method the way it's written. What do I have to do in order to use the addition method, Brecken? Line them up. So how should we rewrite the system?
4x equals 11.
Technically, you could. I actually like x, y equals number. I like it's called the general form of the equation, but I think you're going to have better success if you just line it up that way. Now, that said, it's not wrong what he did. Let's do it this way first, Brady. Let's bring the 5y over as the -5y, and then I'll show that really it doesn't matter. But let's go and work it in this format first, and then I'll show the other. So, Brecken, if we had done this, what would we need to do? Good. And when we do, we get? Equals 10. Of course, we still have the 4x, -9y equals 11. Now what?
Change the sign on the bottom.
Okay. And when we do, this works out really nicely, Brecken. So obviously y equals 1. Once we have that, we can plug that in here to get, move the -9 over as a, to get 4x equals 20. I had 11 plus 9. He said let's move it over as a positive. 9 gives us 20, so that x equals 5. And so our answer should have been, did you happen to have that anyway? You did. Did you also have 5-1? Neither of you did. Did you bring the 5y over as a negative like I showed to get xy equals number? You did not. Okay, Maddie, what did you do before I addressed the other thing that Brecken did?
I did do +5.
Okay, so when you brought the 5y over, you forgot to change its sign. Okay, Noah? Don't tell me you did the same thing as Maddie.
I don't know what I did.
Let me take a look at what you did. Mentally, you brought the 5y over as a negative, and you distributed a negative 2, which made this a negative 4x, positive 10y equals negative 10. You allowed your x's to cancel, but instead of getting 1y, because the signs are different, you subtract, you added to get 19y equals 1, which gave you y equals 1/19, which is just awful. So it kind of unraveled on you. Let me show what Brecken was talking about. He decided all I really need technically is for them to line up, right? So he could have moved the 9y over as a positive, could he not? And that would have left 2x equals 5, positive 5y. And he does have like terms lined up now, doesn't he? Technically, that's all you really have to have. He still would have multiplied everything through by a 2 to get 4x equals 10, positive 10y. And he would have changed the signs, presumably across the bottom, to get negative 4x, negative 10, negative 10y. That cancel, giving him nothing, is equal to 1 minus y. Here's where you have to be careful then. You have to remember to bring the y back over now since you didn't do it earlier. The big upside of this is, once one of the variables is gone, your variable and your number are on opposite sides because one of these has been knocked out. That's why I pushed the xy equals number. Not that it's wrong to do this, but you end up having to move something anyway. Just get it done at the beginning is my recommendation. But again, not wrong to do that. Let's take a look at the next one. Was it x equals 7 plus y as your first equation? Actually, I've got blank copies. Yes, x equals 7 plus y. All right, so this was really set up to do substitution. Noah, did you do substitution? You did. All right. So I assume since the top equation already said x equals, you just plugged 7 plus y in for x, which gave you what lower equation?
28 plus 31 equals 25.
Okay, so we've got an x equals 7 plus y, and we've got a 4x plus 2y equals 25, right? And we want to plug this 7 plus y right here where it says x. Tell me what to write again?
28x plus 4y.
Okay, the x isn't there anymore. It's a 7 plus y. So 28
plus 4y.
There we go. Does that make sense? So again, this is why I recommend showing the substitution. It's not that, okay, if the coach says, hey, Noah, go in for Brecken, he's in foul trouble. You don't go and say, okay, Brecken, I'm with you, man, let's do this. No, it's, hey, Brecken, go to the bench. Coach doesn't want you in the game anymore, right? You're trying to play with Brecken. No. Brecken's got to go to the bench, man. He's out. Foul trouble, get him out of there, right? So, anyway, speaking of which, y'all watch the UCLA Gonzaga game? No, didn't watch it. Okay. Anyway, Gonzaga won in overtime at the buzzer. But UCLA, one of their top guys, was in foul trouble pretty much the whole game. UCLA could have won that game. Would have been Gonzaga their first loss. Anyway, I digress. Back to this. No, what do we got to do?
Add the 4 plus 2 to get 6. And bring it over as negative. To make negative 3. Negative 3. And y equals negative 3 over 6.
Let's reduce it down, right? Negative a half. All right, what do we do once we got negative a half for our y? Right. And what is 7 minus a half? If there's 7 pizzas, and Maddie comes along and eats half of one, how many pizzas? They're small pizzas. She's like, I don't want small pizzas, I want big pizzas. But if Maddie eats half of one, how many pizzas are left? 6 and a half. So x is 6 and a half. So our answer should be 6 and a half, negative half. If you happen to have 13 halves, negative half, that's correct as well. How many have that on this one? Ooh, okay, questions. Now that we've gone over it, did we find our mistakes? Questions, comments? All right, let's look at the next one. Again, I've got writing all over mine. So we've got a 3x positive 2y equals 49, and we've got a 2x negative y equals 7. Maddie, could go a couple directions here. What did you do? You did substitution, which means you did a double switch. That's the best way to approach it. That means we'll keep for now the 3x plus 2y equals 49, but the bottom equation becomes well, if you pull a double switch, I'd say 2x minus 7 equals y. might make it a little easier there, and then we plug this in for the y, right? Did you say negative 7 plus 2x? That's not wrong, it's just a little awkward, but you know, it works. Okay, so let's keep rolling, Maddie. What do we get when we substitute?
3x equals 14 plus 4x equals 7.
Or positive 4x, negative 14 when you distribute and plug in all at once equals 49. Same thing, all right? So you combined your terms, you got 7x, and you kicked out your negative 14 regardless of where it was and made it a 14 to get a 63, which gave you x is equal to 9, which you then plugged in here and got y equals
I got 11.
11. So your answer is 9, 11, or 911 if you really need help on these systems. Questions on this? All right, how many got 911 for this problem? Noah, question, comment. Did you do addition method by any chance? You did substitution. Addition would have worked really well, actually. That's what I did, because I saw this like, hey, if I multiply a 2 through here, I get a 4x negative 2y equals 14. Gone. 7x equals 63, x equals 9. Again, same basic thing we got here, I just got there a little quicker. I thought substitution or addition method worked really well, but substitution does work. Did you find your mistake?
Yeah.
You did, all right. Last row, Brecken, top problem, or last problem, first column, excuse me. Substitution could work, or you could just do addition. What did you do?
Substitution.
All right, so I assume you rewrote the top equation.
X equals 6 y plus 9.
All right, you left for now, the bottom equation is 5x plus y equals 14. When you did the substitution, you had to plug the,
X and 6y plus 9.
no, the other way around, 6y plus 9 in for the x to get,
Like, multiply.
either one.
Okay, 30y plus 45 plus y equals 14.
There we go. All right, so plug that in for the x and then also distribute. You did all of that in one step. We can combine the y's
31y.
and also
45 over negative 41.
so that,
Y equals -1.
and we plug that back in for the,
Top y
to get,
negative 6 plus 9
which is,
3.
so our answer,
3 negative 1.
there we go. How many have 3 negative 1 like Brecken? Excellent. And our very last one, Noah, we come back to you. Substitution or addition?
Substitution.
Substitution. So you rearranged the,
But
to say,
y equals negative 3x plus 4.
all right, so strategy tip. If the y is negative or the x is negative, get it out of there. Double switch right here. Because you don't want a negative y, do you? But technically, if you move the 3x over as a negative, Noah, it's not y, but negative y that equals negative 3x positive 4. Therefore, plain old y would have to equal,
Positive 3x. Negative 4.
but you could have gotten that so much quicker. Just put the 4 here as a negative and the y there as a positive. 3x minus 4 equals y. Does that make sense? So I'm a big fan of the double switch. Now that means your answer will be wrong because you have the signs exactly backwards. So ignore what's on the paper. Let's work it from here. We're going to take the correct 3x negative 4, plug that in for,
Y.
and make sure you realize that's the y right there. Normally we're seeing x then y. Don't plug it in here. That's an x. Plug it in here where the y is, the 3x negative 4, to get
6x negative 8.
We can combine.
11 equals 4. 20. 22.
And we get,
2.
that's what we should have gotten for the x. We come back over here, plug that in. What do we get for the y?
2.
So our answer should be
2 and 2.
2, 2. Do we get 2, 2 for the last answer? You did. Obviously, if our signs were backwards, we didn't have a chance on there. Questions on that? Do we feel like we're beginning to understand or identify our mistakes that we tend to make so we don't make them in the future? Let's give you some more practice. Page 167. Page 167. I want you to do numbers 6, 9, and 10 by the substitution method. Page 167, numbers 6, 9, and 10, solving by the substitution method. Get a letter by itself, substitute it. Make sure the letter that's by itself is a positive letter. Don't get a negative letter by itself. Get a positive letter by itself, even if it means moving that letter to the other side so it becomes a positive via double switch. 6, 9, 10 substitution. Number 6, how many of you got the x by itself in the top? How many got the y by itself in the bottom? Did you do a double switch to get 2x minus 7 equals y? Okay, because good. You want a positive variable. All right. Since 2 of you did it this way, I'll do it this way also. Did we get to -3 for number 6? Good, good, good. Keep working. Number 9, did we get the x by itself in the bottom or the y by itself in the top? How many went y in the top? How many went x in the bottom? We're on number 9.
Go Y.
You went the y. You went y. You went x. 2 of you went y. I'm going to go y. Yeah, there we go. Signs were different. Subtract, keep the sign of the greater. Did you get 5, -1 for number 9? I'm human too, right? No, you did not get 5, -1. What'd you get? 1, 1. All right, let's take a look at yours real quick. All right, you got the x by itself, -2y plus 3. -2y plus 3 plus y. Right here, -4y, positive y gives -3y, which gives me y equals -1, which when you plug it back in, would have given you the 5. All right, then number 10, how many went y in the top on number 10? And you went x in the bottom? I went with them last time. I'm going to go with you this time, just for a change of pace here. So Noah, you kicked out the 4y as a -4y, and that's your x. You plug that in for this to get 3 times 12 -4y, positive y equals 3, of course distributed 36 -12y, positive y equals 3, combine to get a -11y, bring the 36 over as a negative to get -33, got y equals positive 3, and you plug that in, you get x is 0. So 0, 3. Your answer, yes. What you got?
I got 3, 0.
Oh, okay, I think you just wrote it backwards. Did you get 0, 3? All right. You got y equals 3, but you wrote it like it was the x. So just be careful there. I want you to do now numbers 5, 7, and 8. But even though it says to do 5, 7, and 8 by substitution, they're so much easier doing the elimination method. Look at 5. Do you see that the elimination method is super easy? Look at 7. Doesn't the elimination method just scream at you? Even number 8 to an extent, doesn't the elimination method just be like, do it this way? So I want you to do the elimination method for those 3, 5, 7, 8. Just check your answers. They're all right now. I had one small mistake on my part, which I have since corrected. Now you good to go? Were you perfect on all three? No, which one? The last one. Did you knock out the x right off by changing signs, or did you multiply a 3 right off and knock out the y?
I had the answers like when I subtracted -12 I had a positive 7.
Okay. So half of it right, because you had to rework the whole thing anyway the second time. It's not like you plugged in 7/8 early. So hopefully too lazy for that. All right, so just a little sign error. That's what I had as well on mine. All right, Breck and Noah checking your answers. These are all correct now. They were not initially. Right here, when I moved the 3 over as a -3, I didn't keep the sign of the greater. I had a -1, which, like, oh, the negatives cancel. Why is +1? No, that's +1. Now change the signs and get the -1. So I had my human error as well. I think that's 2 this hour, which is not a good track record. Looking painfully human today. How did we do? Did you get all 3 correct? Without needing to look at the answer key like I did. So you did better than the math teacher. Good job, Brecken. Show off. All right, Noah, how about you?
I missed the last one.
Missed the last one. All right, did you start by just changing the signs across the bottom and knocking out the x, or did you start by multiplying a 3 through the bottom and knock out the y?
Multiply. Wait. I canceled the 3s.
Okay, so you multiplied the 3 through. So your first answer was -7/8 for x?
No, I did the other thing.
You just changed the signs across the bottom to knock out the 2 x's. Let me look at your work here. Number...
Yeah.
Okay, see, it looks like initially you multiplied here,
I put a negative.
and you got the 4y equals 9, y is 9/4. Okay, and then you multiplied the -3, or the 3 to get 6x, -3. Oh, that should have been a -12. That's why, because you had the negative. You could have crossed it out the first time you worked, so you could get the 9, but you forgot it had been a cross out. So maybe the idea there is, once you've gotten the first variable, if it's a fraction, erase and start over, rather than trying to save yourself the time, because then it's a messing you up. All right, you're going to get a chance to practice several of these for homework this evening. Pages 167 to 168. Pages 167 to 168. I want you to graph number 2. Graph number 2 at the bottom of the page. This is where we just were, the review of solving systems. Graph number 2. And then on numbers 15 through 24, you pick how you want to do them. 15 to 24, you pick how you want to do them. Then on the next page, page 168 through 35 to 37, those are just 3 questions with 1-word answers. So no math involved there. So number 2, you're graphing, 15 to 24, you pick your method. You could do elimination, you could do substitution, you pick whatever you think is easier. And then 35 through 37, answering those. All right, you are dismissed. Have a great rest of your day.